Hello again. This is Math 1120 coming to you from the College of the Page, and the title of this lecture is Regression Introduction. As always, be an active learner while watching this and other videos in this series. By way of introduction to this topic and to address the question of why are you studying this statistics stuff at all, I'm going to show you a research paper. And the title of this research paper is called Stepwise Logistic Regression Analysis. And that will be abbreviated so I don't have to say that again, LSR, Analysis of Tumor Contour Features for Breast Ultrasound Diagnosis. And again, it's important that you realize the whole reason you're doing these ultrasound exams is so someone can do diagnosis on your digitized image. Okay, so here we go. And this was published in a peer-reviewed journal. There are many peer-reviewed journals. This is Ultrasound in Medicine and Biology. Okay, so here's what they were doing. To assist the ultrasound differential analysis of solid breast tumors using LSR, analysis of tumor contour features, we retrospectively reviewed 111 medical records of digitized U.S. Images of breast pathologies. Okay, so the sample was 111 medical records. They were looking back in time into the records, so that is the retrospective aspect of this. And the 111 medical records is in fact a sample. Now, of these samples that they looked at, 40 were benign and 71 were malignant. Now, the contour features, that is the shape of the tumors, were calculated by measuring the radial length of the tumor boundaries. The features selection process was accomplished using a stepwise analysis procedure, and then an LSR model with contour features was used to classify the tumors as benign or malignant. In this experiment, and it was an experiment because you had some of these were benign and some of these were malignant, and you looked at the two groups. Cases were sampled with a leave one out test method to evaluate the LSR performance using a receiver operating characteristic ROC curve. The accuracy of our LSR model with contour features for classifying malignancies was 91%. That is, they were correct on 101 of 111 tumors. The sensitivity was 97.2%, 69 of 71, and the specificity was 80%, 30 of 40. And the positive predictive value was 89.6%, 69 of 77. And the negative predictive value was 94.1%, 32 of 34. Now, the CAD system using the regression analysis can differentiate solid breast nodules with relatively high accuracy and high negative predictive value, and this could potentially help inexperienced operators to avoid misdiagnosis. And because this LSR model is trainable, that means adaptable, sort of an artificial intelligence thing. You put more data in, it gets better. It could be optimized if a larger set of tumor images were supplied. Now, as we're going through that, there's a couple of questions that you might have had. What was all these sensitivity, specificity, negative predictor value, and all of that jazz? And that will be covered in a video lecture that is in this lesson, so that those questions will be answered there. And I guess the last thing you might say, I'm just going to do the ultrasound, I'll never be interested in doing research. Well, I would say to you, don't sell yourself short. Okay, so there is this introductory video. There's also the one dealing with specificity, sensitivity, and all that jazz. And then there are some statistical lessons that you'll do. Now, again, what you'll do is you will go to this link, and then what you will do is you can click on lessons 9, 10, 11, 12, and 13, which are the start of our discussions of regression. And you may recall that previously we were doing all of this, and we really probably hadn't really finished with normal curves and normal calculations, but time goes on, and so we're going to be doing more of this, but we'll be working on this as well the next time we meet. And the upcoming low stakes assessment, which now is low stakes assessment 3, has to do with speedy lube and is looking back to the normal distributions. Okay, so the time required for speedy lube to complete an oil change service on an automobile is approximately a normal distribution with a mean of 17 minutes and a standard deviation of 2.5 minutes. Speedy lube guarantees customers that the service will take no longer than 20 minutes. If it does take longer, the customer will receive the service for half price. What percent of customers receive the service for half price? That is your first question. The second question is, if Speedy Lube does not want to give the discount to more than 3% of its customers, how long should it make the guaranteed time limit? 2 questions, and we're going to be discussing more examples of this in class when we meet next time. Until then, and in closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself and of each other. May God bless you all.